Yeah, thank you. I hope you had a refreshing lunch break, and I'm happy to see so many of you here. So, yeah, the title of my talk, 10 Years of Automated Category Classification for Product Data. Quite a mouthful. Yeah, we're dealing with product data for quite some time now at Salute, and I'm going to talk about the evolution of our architecture and system evolving around automated category classification. So Christian already introduced me a little bit. So yeah, my name is Johannes, and I work for Salute for almost 4 years now. And those are some brands of Salute. So they're the billiger.de, shopping.de, and Friends Communication. But most interestingly, our talk will deal with the stuff that in the end is on billiger.de. For the non-German speakers, it's cheaper.de. So it's a price comparison website. So people come to the website looking for some specific product and finding at our site the shop that provides this offer with the cheapest price, for example. You can also browse, and when someone then clicks on a link and goes to the shop, and the shop is happy to get a customer, because people are usually willing to buy when they come from our side, then the shop shares some of the revenue of the sale, and that's like our business model. We send some user traffic to the shops and say, send us money, which is quite a simple model, but it's working, so that's nice. So today, billiger.de looks something like this. So you have like an overview over categories and things you might browse. So this is also like a use case if you want to just find out what are current models for something, and if you want to filter for something, you can do that. And on the right, there's like the larger view on our category, our main categories that users can browse through. So that's the state of 2019. But as the company was founded in 2004, we're here for quite some time. So back then, this is the image from around 2007, I think, things looked a bit different. So there are like mobile phones that weren't just a screen, but they had buttons. Wow. And some of you might remember. But already there at the top, you might see there were categories. So here we have like handies, so mobile phones without a contract was like a category you could browse through. So things were simpler back then. So let's have a look at the architecture. So the main website was just this. There was like a master database, MySQL back then, and a search service. And this is the just website architecture from around 2008. I'm not exactly sure, because as you might have noticed, if I'm working for almost 4 years in the company, and this is about the last 10 years, I wasn't around back then. But I talked to some people who were and learned about, a lot, and it was quite an interesting journey. And that's what this is also a little bit about. So how did we get the data into the master database that is used for serving billiger.de? There was obviously there are the shops providing all the catalogs, giving us their data, but there was a third party involved, and this third party downloaded the data and sorted them into categories and products. And then Salute imported this, and as you see, there's like this shadow database. So what's this about? Back then, the architecture looked like this. The import needed to be like complete until you could use the imported data. So they imported data into this shadow database. And then when it was like the import was done, they just switched the master and the shadow. So the master became the shadow, and the shadow became the master. And then all the data on billiger.de was current. Very nice, right? But in my imagination, it looked a little bit like this. It's like, so now change. So I'm not sure how easy things were, but of course all of this was automated, at least that I heard. But things are designed differently nowadays, right? And this had problems. One thing is there was a huge lag. So imports only took place every 4 hours. And if a shop updates the price, and we're a price comparison website, then 4 hours plus maybe some lag in the download before makes the shop unhappy because they want to say, hey, the cheapest now, where is it on your site? Then when the third party made some errors, the categorization or in the product creation, there was not a good easy way to give some feedback. There was no API, just people need to talk to each other. There's an error or whatever. So this wasn't really convenient back then. And also, the third party, of course, also had a share of the revenue. And as a company, you want to cut the middleman, right? So the decision was made to do some in-housing here. So we need to replace all of the things that the third party did. So we need a system to download the shop data, doing the shop import. And we need to replace the third party black box, the categorization, which was called mapping in the following, because like you have a set of categories and you have some offers streaming in and you want to map the category to the offer. So this kind of stuck. It's actually a bit too coarse-grained for what it really is because it's a categorization. But okay, mapping is a name that was used. And there's sorting the offers into products. So a bunch of offers that describe the same thing are considered to be a product. And this was called matching. It was like rather matched together. And this was called our eigenes matching project, our very own matching project. And let's see how this went. So like the first step was creating the shop import. And we needed to have the data in our hands. So a result from that was like having a base of all the data the shops gave us, and also we can create deltas now. So especially for updating the website and the search and everything, having deltas is way faster than waiting for the complete import cycle. So there were already some wins in this. But still the third party was in place. But because we have these deltas now, we needed to coordinate the data that's already here and that's coming through there. So there's like another process called matching export to find this together. Then replacing the third party. What did we need to do next? So from the deltas, we knew, okay, which offers have changed, which should we look at? And those that changed, we first checked for, is the change relevant? Because, I mean, an offer usually consists of some base information like what's the name, what's like the category assigned by the shop, or every offer has a price, and there's something like delivery time, and some of those fields aren't relevant for the category or the product. So the if the delivery time changed, you don't need to change the category or the product of an offer. So only the relevant changes should be considered for our systems to be put through, and then we need to have the mapping and the matching. So find out the category and the product. And everything needs to be stored somewhere. So there was also introduced the so-called mapping and matching DB, short MMDB, which will stay with us for quite a while. So this design fixes most problems. So the huge lag problem goes away. We're dealing with the shops directly ourselves. And not just import every 4 hours. And yay, the third party's gone. More money for us. So, but this does not really fix the problem with correcting errors. I mean, when we have our own systems, assuming that you have some classifier that works, you still need some way to deal with errors. Okay, so this is like the start of the architecture, and we will not focus on everything around there, but talk a little bit more about the mapping classifier that was created and went live in 2009. So the choice of algorithm back then was support vector machine, and the approach was like using this one versus many classification. So it's obvious that you can model this categorization as a classification task. So we had like more than 2,000 categories in our backend. And you need to predict these classes for each offer. So, yeah, it's kind of obvious to use a state-of-the-art back then, a support vector machine. And the good thing is, we still have the third-party data from before. So we have labels for each offer. There's a category already there. So yay, so much training data. Pretty nice for a start. So there was one model trained per category. So it's like more than 2,000 models were trained in a one versus many way. So each model answers like the question, should this offer be in the category you're representing? And you classify an offer with each of the model and pick the best ranking score. And for each of the model, you could also set an acceptance threshold because you might want to adjust that. We'll mention it later a little bit. So what features were used? So it was actually just a bag of words. You throw all the tokens you find in different fields into one bag of words and try to learn how they can help to identify the category. So you have some attracting word tokens and some repelling tokens in there, and that you want to learn. So use the name, description, and the shop category, which is like the category that the shop delivers from their system, because usually every shop has its own kind of categorization scheme, and we need to, unify that. And what also is helping throwing into the mix of the bag of words, price bin tokens. So using the price, but not like the exact price, because it would be much too fine-grained. But use like binnings from 0 to 5 euro, 5 to 10 euros, and so on. To have some span. And this was just created as a token and thrown into the bag to be learned from, and that's it. So in like 2008, 2009, what were some challenges that they had to overcome? So back then, the Python ecosystem, it hadn't really found its love for machine learning yet. So NumPy and scikit-learn and all of these beautiful tools we have nowadays didn't exist back then, or not weren't nearly as far as they are today. So they needed to use something else, liblinear implementation, the lib SVM in C or C++. So as we are in our core a Python company, this is like a different technology that was used than we usually do, but it was really necessary back then because, there was nothing else around. Then for parallelization and pre-processing all the data, there was a MapReduce framework called Disco, and it was by Nokia. Does anybody here know it? Ever heard of it? Okay. At least 2 people out of 3 worked at Salute or work at Salute, so you don't count. So 1 person heard of it. It pretty much got discontinued in 2014, but we were stuck with it. But back then, it was like, you want to use Python, and MapReduce was a thing, so Disco was introduced. Also, even on a server, 16 gigabytes RAM was huge. It's like a quote of the colleague who provided me with most of the information about this talk. So to do some parallel training for SVM classifiers, they created like this custom memory mapped binary file format, and so all the processes could work with the same data, and so there was quite a lot of engineering needed to get this working. But then, they did their infrastructure, They worked on the data and so on, did the cross-validation for each category, looked at it, the precision and recall ratio, is it good? As mentioned, they had the true labels from the third party, so it was easy to compare. Then some editorial staff need to adjust the thresholds for each category. So for some categories, false positives are more costly than for others. So you might want to have a high threshold for some categories and a lower one for others. For example, back then we had like this certificate which guaranteed there's no erotic stuff on our webpage. So we really had to make sure that everything that's for marital hygiene is categorized into the correct category, erotic, and filtered out and never shows up on our webpage. So there you adjust the threshold to be a little bit lower, so you make sure everything really goes into that category that needs to be there. Then there's 2009, mapping classifier goes live. So this was like the system's architecture. So what happened next? Living data. Of course, the product world is ever changing. So new stuff comes out, new developments. I mean, today there's like smart home stuff and electro scooters that didn't exist back then. So there's always some change. So also the source of labeled data vanished because, hey, we achieved our goal, we got rid of the third party, but now we need new training data. So how to get that? Especially when you want to add a new category, there's nothing there. And the other thing is, okay, the system wasn't perfect. I mean, it was just like needed to be good enough to replace the other system. So there were errors and they ended up on the web page. And then there were people saying, oh, there's an error on the web page. This needs to be cleaned up immediately. So there was kind of the understanding that stuff needed to be fixed and corrected fast. So there were editorial tools added to the mix. So there's editorial staff, category managers, and so like, who are experts for the details of specific kinds of products and categories, and they say, okay, this needs to be, and they go into the data and fix errors and confirm documents. Okay, this category is correct for this, and they work through the data. And as this, it happens, all these confirming and correcting data was designed to be the new training data, because a human expert has decided this is correct. So we can say, okay, then let's use this label as the training data. And that was a rather stable architecture. This was running as a whole, like the thing from 2009 to 2019. So this is like the 10 years of category classification from the title. I mean, under the hood, a lot of things changed, but this rough architecture didn't. So like this MMDB was MySQL and later switched to Postgres and so on. Some tweaks are done. The editorial tools evolved, but the core was pretty much untouched. Especially the training infrastructure with like the Disco and mapping training was a little bit stuck. So there was a decision to rewrite the mapping classifier in 2018. We needed to replace this unflexible infrastructure, because even if you had a good idea how you could improve everything, it was very hard to integrate anything, because there's like, you need to dive into C, you need to look into the memory files and so on. And there was a lot of technical debt. We need to get a Disco, which couldn't even be run on the recent Linux anymore, and replace non-Python tools. Because I think when this system was built, it felt like, we climbed a mountain, we really achieved something. But if you then stop going on, you're more like stuck in quicksand because you start thinking in technical depth. So that's what happened. So I think I need to speed up a little bit. So we thought about a new design, introducing a new category classifier and using neural network-based model. And the structure we thought is fine. It's working. Let's keep this. So we trained a neural network-based classifier and used, again, name, brand, shop, category, description as the fields, included price binning, which is still useful, include position information, so that's an improvement, no more just bag of words. And another change was no 2,000 different classifiers anymore. One classifier was now handing out one result over all classes, which is rather nice for comparing the results. But during development, we found many problems in the training data. There was wrongly labeled data. Yeah, simply wrong label, wrong class for something. Then we had a problem with semantically overlapping categories. So if you look at this, we have a category books, Spanish books, books, French books, and books, foreign language books. Because we're a German company, everything that's not German is like foreign language. At least how it was modeled in the category tree. But if you have a French book, where does it belong? In the French books category or in the foreign language books category? So how should a classifier decide when a human couldn't decide? Then there are dumping ground categories. For example, if you have mobile phone accessories, like there are bags for mobile phone covers, app screens, holders, chargers, whatever. And all of this was put into like a mobile phone accessory, which means the stuff within that category was very orthogonal to each other. It wasn't similar. So if you train a model that should learn what is a mobile phone accessory and stuff within that category is very far away from each other, it's hard to learn. And then there's an imbalance of feature distribution within a category. This is another problem, because often when the editorial staff was cleaning up data, they did it shop-wise. So take this shop and correct the categories of the offers of this shop. And then a lot of data of one shop landed into the training data. And then this shop-specific information might have been a dominant feature. For example, the shop category for something was learned to be a very good indicator for a category, but maybe it's too shop-specific and the real data looks different for offers that should be the same. Okay, so there's also an imbalance of category distribution over the whole data set. So there are some categories where we have a lot of training data and some oversampled compared to the real data, and there's other categories that are undersampled. And here's the thing. If we have editorial staff working on this, why is our training data such a mess? It's really unbelievable, right? And the bottom line, and that's like the important thing, we learned the business goal we gave our editorial staff was fix the data so the results look nice on billiger.de. And the data science part of us said, you should constantly adapt the category tree to the reality and maintain training data for each category. But it didn't happen. One reason was insufficient tooling. There was product-based tooling where you edited the most important products, which means the most sold products, and category-centered editing where you do mass edits. That's where the most errors come from. And also maintenance is cumbersome. So over an extended period of time, the urgent things blocked the important things. So I think I have to skip a little bit now due to time. But what we need to do was we need to rethink our whole training data management. So we need to change editorial staff's role. They need to manage the category tree and improve training data instead of fixing live data. So to do that, we said we don't need like these edits our training data approach anymore. We need to remove like these direct connections and say we need annotation tasks. So the systems should monitor the quality and if of the results, and if the quality is not good, generate annotation tasks for editorial staff, and then the editorial staff should work like in an active learning setting on the right things to do. So in March of this year, we went live with a new model, but with an old architecture. As you can see, we're still like in this fixing things mode because it's hard to switch this in fast. But we're planning to add more like these active learning goals there in this year and moving forward. But let's jump to the takeaways. So think about your training data management. If you are in it for long term, there are some mistakes to be avoided. So think about your system's lifecycle. If you're working on your PhD, gather some data, make an experiment, and report the result. You don't have a training data lifecycle that's long. But in our case, we had a moving target and aging data. So you need to think about this beforehand. And if your domain is changing over time, make sure your training data keeps up. And especially think about how to delete old data because it's harder to do that. And also investing in technology transitions. They cost time, but they come with a flexibility because just after we changed a lot and removed technical debt, we revitalized the creativity of the team. So it really made a difference. And then there were well-found decisions, improve the status quo, but you need to be challenging them from now and then because some things we even didn't fix now or are on the verge of fixing. The hard to correct errors, we still don't have an API, but the annotation task kind of represents it. So thanks for listening to my talk. And there are some special thanks go on to Patrick Schemitz, who gave me many of the information about the old system. And also Christian, who is here, who was a big part of the new model creation. So thank you for listening.
Thanks a lot, Johannes. We have time for one question only, and I think you were the first person to raise your hand. So it's your question. Think about it really well.
All right. First of all, thanks for the great talk. Just out of curiosity, you have any measure on accuracy? Like how well did your system perform?
Yes, we do, but reporting detailed numbers didn't fit into the time of the talk, therefore I left them out. What are accuracy measures? It depends on the category. Like there are 2,500 categories plus, so in some it's like 99% and everything's fine, and in others it's worse. But one thing that dramatically changed between the old and the new system was like things that we couldn't put into a category. In the old system, there was like, it didn't met the threshold, we're binning it. No category for you. But in the new system, we changed like from 80% categorization rate to like 95, 97% of categorization rate. So that's the biggest improvement that I can report just like this. And for everything else, we can talk in some other context. Yeah, you can approach me if you have any questions afterwards. I'm here.
Yeah, thanks a lot.